Okay, hello again, ladies and gentlemen. All right, so I'm going to go over all six of these proofs. Okay, I asked you to look at three of them plus number six. Okay, so I wanted to give you the practice with the addition and subtraction postulates. Okay, so again, this up here says decide which strategy to use. Okay, based on the givens. Okay, so on the test on Monday, you're going to have to decide which method to use. I'm not going to tell you which one. Okay, and as long as it is a legitimate method that can be supported by the information you're given, then you can use whichever method works. Okay, so you may have used a different method than I'm going to show you on these. Okay, which is okay also, but I'm going to just do one method for each. Okay, so starting with this one, okay, JM, this is J up here. It got kind of punched out with the hole punch there. Okay, JM bisects KN. Okay, so be careful. It doesn't say they bisect each other. It just says JM bisects KN, so that this side is congruent to that side. Okay, angle K given is congruent to angle N. Okay, and then when you have intersecting lines, you've got these two angles. Okay, so once you've marked the diagram, the method should become clear. This is going to be angle side angle. Okay, so I'm going to do this. One, JM bisects KN. All right, I'm just going to do this. Given. All right, two. Because of that, I can say that KL is congruent to NL. Okay, that's by definition of segment bisector. Okay, three. Given K, angle K is congruent to angle N. That's given. Okay, four. I can say angle. Now I have to use three letters here. Okay, because there's more than one angle there. Angle JLK, and you could have called it KLJ if you wanted to. Angle JLK is congruent to angle MLN. Okay, and that is because intersecting lines form congruent vertical angles. Okay, intersecting lines form congruent vertical angles. Resize that box. Push this over a little bit. Oh, I can't do that. Okay, so it wrapped around because I'm using only one text box. Okay, so now I've got everything I need. So I can say triangle, okay, JLK is congruent to triangle MLN. Okay, and my reason is ASA. In this case, we used ASA. Okay, so that's that one. Okay, so for number two, we've got to be careful here. Okay, if I mark the diagram, okay, WY bisects angle ZWX. Okay, so you got to be careful about what is doing the bisecting and what is being bisected. It's this top angle that's being bisected. So all that tells me is that that angle is congruent to that angle. It does not tell me that ZY is congruent to XY. It does not say it's bisecting that segment. It says it's bisecting that angle at the top only. Okay, so don't assume just because it looks like it, you can't assume that it's bisecting that segment. It's only bisecting the angle. Okay, and then we've got angle Z congruent to angle X by given. Okay, and then we've got WY congruent to itself by reflexive. So this is going to be angle, angle, side. Okay, so one, WY bisects angle ZWX. Okay. Given 2. Okay, because of that, I can say angle ZWY is congruent to XWY. 2. Okay, that is by definition of angle bisector. Okay, 3. We have angle Z congruent to angle X. Okay, given. Okay, 4. We have WY congruent to itself. Reflexive postulate. Okay, 5. And that's it. So now we've got angle, angle, side. So triangle WYZ is congruent to triangle WYX. Okay, and our reason, our method that we used in this case was angle, angle, side, congruent to angle, angle, side. Okay, so for number 3, XZ is a median. So that is a segment that goes from the vertex to the midpoint of the opposite side. So in this case, that is bisecting WY because by the definition of median. Okay, it doesn't tell us anything about the angles at the top. It only tells us that it bisects WY. Okay, then the other given is this one. Okay, those two sides, and then of course we've got reflexive. So side, side, side should just jump out at you for this one. Okay, so 1. Okay, XZ congruent to, XZ is median to, that's a median, it just says. Okay, median given 2. That tells me that WZ is congruent to YZ. That's by definition of median. 3, we've got WX congruent to XY. And we've got XZ congruent to XZ by reflexive. And then 5, we've got triangle XYZ congruent to triangle XWZ. And we showed that through side, side, side. Okay. Okay, so at this point, that one should have been pretty straightforward. Okay, so I'm going to stop this video now. Okay, and then I'm going to put up another video for numbers 4 through 6.